Hello, lovely people. What is up? Today we are solving Leetcode problem number 3461. Check if digits are equal in string after operations at 1. So here we are given a string S consisting of digit. We are supposed to perform the following operations repeatedly until the string has exactly 2 digits. So for each pair of consecutive digits in S, starting from first digit, we have to calculate a new digit as the sum of two digits and modulo 10. And then we replace f with the sequence of newly calculated digits, maintaining the order in which they are computed. We return true if the final two digits in f are the same, otherwise we return false. So let us look at the brute force approach, after which I will explain the optimal approach. So we are declaring a while statement where length of f is smaller than 2 because they have asked us to compare the last two digits. We are declaring a new string, or let us call it news, s. And we first initially we declare it as an empty string, and then we are initializing a for loop to traverse throughout the length of the given string. We are doing -1 because we are asked, the operations ask us to add the current digit and the next digit. So if we are iterating to the entirety of the string, that is towards the last digit, we will have out of the bounds error. That is why we are doing s-1. And then we initialize another variable digit and start our operation. Since it is in string format, we type convert it into int, and we do s of the current element plus s of the next element in f s plus 1, s of I plus 1. And then we do modulo 10 because that is the given condition. And then we add the new computed digits to our new string. We do new s plus equal to string of digits because we have to type convert the integer into string. And then we are updating the s value to the new string, and we check if the first value is equal to the second value in the string. So this code will run in O of n square time. Okay, Unicode is all string in Python is Unicode default. So we have to do str to call the string digit. So now let us try to understand the optimist approach. Since this code runs in O of n square time, we need linear time solution. So what we can do for that is we can use the Pascal's triangle approach. So in the Pascal's triangle method, let us imagine all the values in the string are variables a, b, c, d, and in the first iteration we do a plus b, b plus c, and c plus d. And in the second iteration, what we do is a plus b plus b plus c, and the next digit will be b plus c plus c plus d. So if we do basic mathematics, we can see that 2b plus a plus c is the first digit, and the second digit is 2c plus b plus d. So the final two digits will be a plus 2b plus c and b plus 2c plus d. Now if we take a look at the coefficients of both the digits, they are equal, which is 1, 2, 1. If you will notice, this is the same as the second row in a Pascal's triangle. So a Pascal's triangle is 1, 3, 3, 1. and 14641. Yeah. So if you take a look at it, the second row is equal to what we got as the coefficients 1, 2. So we can clearly see that if the length of string is n, the coefficient is in the n minus 2th row in the Pascal's triangle, n minus 2. So let us take n is equal to 4, like we have taken in this example, and 4 minus 2 is 2. So as you can see, it is in the second row. Now, what we have to do is, we have to find the common Pascal's triangle formula to apply in the code. So the final digits will look something like this when we convert it all into variables. So digit 1 will be summation of all the strings and current string values multiplied by the coefficients. That is coefficients of the Pascal's triangle n minus 2, I. And then same for digit 2. Digit 2 will be summation of all the s of I plus 1 into coefficient of n minus 2, I. So now this particular code will be running in O of n, that is linear time complexity. So now let's take a look at the code. So first we initialize n is equal to len of string, and then we are pre-computing Pascal triangle coefficients by coef is equal to 1. 1 in list form, that is square brackets. So we start with the first binomial coefficient, that is c of k comma n, where n is equal to 0 is equal to 1. So first value is always 1. Now we loop to build a row. So for I in range of 1 comma n minus 1, here n is the length of the string, we append the following values into coef. So coef dot append of coef minus 1 into n minus 1 minus I floor divided by I. So instead of computing factorials, we use the identity c of n comma k is equal to c of n comma k minus 1 into n minus k plus 1 by k. So this avoids expensive factorial calculations. And then we initialize final digits a and b. A is equal to 0, b is equal to 0. These will store the two final digits after all reductions. Then we loop through the digits, like for I in range of n minus 1. We are doing n minus 1 because of the possibility of out of bound error. Then we convert characters into integers. d1 is equal to int of s of I, and d2 is equal to int of s of I plus 1. And then we compute the first final digit. A is equal to a plus coef of I into d1 mod 10. It means a plus equal to coefficient into current digit. It is implementing the summation formula we saw before. Same for b. b is equal to b plus coef of I into d2 mod of 10. And then we return result, return a equal to b. This returns true or false. So as you can see, the code runs in the most optimal time complexity possible. So that's all for today. Hope you guys enjoyed today's video. See you in the next one. Bye guys.